Okay, we're going to do a couple problems off the matrix quiz or test or whatever it is. Starting with number 6, I'm just going to give you the idea. I don't think you need me to do the whole thing out, but I'll remind you of what it says. It gives you 3, a 5, gives you a 2 and 11, and it gives you a 5 and a 6. And what it basically says is, if those are vertices of a triangle, find the new area if you applied a scalar of 9/5. So what that is really saying is we have to use a rule. The rule to find the area of any triangle given 3 vertices is this: x, y, 1, x, y, 1, x, y, 1. Okay? Now this is x, this is y, and that's 1. That's x, that's y, that's x, that's y. Okay? Then you're going to take the determinant of that value, you're going to divide it by 2, and take the absolute value of that. Now the tricky part in this problem is it says find the new area if you applied a scalar. So we're going to take that 9/5 and we're going to multiply it to each part. Now right here that gives me 27/5. That gives me 45/5, which is 9, 1. Do you see how this is my new x, this is my new y, and that's 1? So then I have 2 times 9 is 18/5. Now I have 99/5. Then I have 1. Okay? Well, anyway, so I have 45/5, which is 9. And then I have, what's that, 54/5. And then I have 1. Now, in your calculator, this is definitely a calculator. You can do it by hand, but I wouldn't do it. All you're going to do is you're going to make a matrix, and you're going to make a 3 by 3. Okay? When you make that, you're going to plug in these. Don't worry about the fraction, it'll evaluate for you. And when you're done, you're going to hit matrix key, you're going to hit the math key, and under that math key, you're going to select determinant, DET. So then you're going to go back in and have the determinant of matrix A, and hit enter. Okay? Then you're just going to divide by 2. And if the answer was positive, you leave it. If it was negative, you make it positive. Okay? That's number 6. Number 7, a little bit trickier, but let's see here. Now, I believe I think the area for that, as it stood alone, was 6.5. You'll see why I'm saying that in a minute. So that was number 6. Number 7 looks something like this. Given the original triangle in 6, determine the angle measure of the vertex 211. So, if I rewrite that down, we have 3, 5, we have 2, 11, and we have 5 and 6. So what I'm going to do is just graph roughly. I just want a picture to look at for a minute. So if I have 3, 5, 1, 2, 3, 1, 2, 3, 4, 5, and I put a point. If I'm at 2, 11, pretend that's 2, 11, I put a point. And if I'm at 5, 6, I put a point. Okay? So let's see here. 2, 11. What was that? 3, 5. And what's that? 5, 6. Okay? Now, the tricky part here is I'm going to give you a rule. Okay? Now, the rule is going to be area equals 1/2 AB sine of theta. And that looks kind of scary at first, but it's just a rule. Okay? The other thing I want to remember is Pythagorean theorem. A squared plus B squared equals C squared. Okay? Now to do this math out easily, I guess, we're going to make a little right triangle right here. Now the question asked, what is the angle at the ordered pair 211? Okay? So that means to use this rule, I'm going to have to know this length and this length. Okay? So here we go. From 2 to 5 units, we know that was 3, right? So that means that's 3. From 11 to 6 units, we know that's 5. To do Pythagorean theorem, I have 5 squared is 25, 3 squared is 9, that gives me root 34. So I'm going to draw this a little bit, here. I'm going to say root 34, that's the angle I'm looking for. If I need this angle, little right triangle, I know from 2 to 3 was 1 unit. I know from 5 to 11 was 6 units. Well, 6 squared is 36, 1 squared is 1, that gives me root 37. Okay? So now, I've used this rule, and I'm ready to use this rule. Now what you have to remember with 1/2 AB sine theta, sometimes they call it the hinge theorem or an area formula used in a hinge theorem, is it has to be a side, an included angle, and a side. Okay? Now this is definitely a calculator problem. We're going to remember that we did this work a little while ago, and we got an angle of, an area of 6.5 units. Okay, that was the area. So I'm going to use this formula backwards now. I'm going to say area equals 1/2 AB sine of theta. But if we look at it for a minute, A and B we have determined. It doesn't really matter which one. I'm going to say root 34. I'm going to say root 37. Okay? So when I have the area here, that area was really 6.5. Now I have 6.5 equals 1/2. I'm going to write it as 0.5. I'm going to say root 34. I'm going to say root 37 times the sine of theta. Now when I do this, I'm going to actually do it out right now myself. I'm going to walk you through it, but just put it on pause when you're doing it if you have a hard time. Okay? I'm definitely checking mode and make sure I'm in degree mode. And I'm glad I checked because I was not. Okay? Now, how I do it. I'm going to do 0.5. Now I got to remind you one thing first. See that key right there? That's your answer key. You access it by hitting second answer. Okay? So when I do this math though, can you just see that? Maybe you can't. I'm going to say 0.5 times the square root of 34. Actually, you know what? Let me do it a little bit easier. 0.5 times the square root of 34, I close parenthesis, times the square root of 37. I hit enter. I get 17.73. Now before I divide anything, I'm just going to hit 6.5 divided by my second answer. It recorded that. And I get 0.3665 blah blah blah. Now, not that you care, don't touch the calculator yet. I am going to technically take the inverse sine of both sides. Now when I take the inverse sine of this, that kind of negates I'm left with my theta. When I take the inverse sine of this, that's going to be my value. So now I'm going to press second sine, or inverse sine, second answer. And I get 21.5. That is in degrees. So right here is 21.5 degrees. And that is done. And I know that's a little tricky. Okay? Number 10. Let's see where number 10 is. Number 10 looks just atrocious, but we got to remind ourselves we like math. So I'm going to have the sine of pi thirds. I'm going to have the cosine of pi. I'm going to have the tangent of pi fourths. I'm going to have the tangent of pi thirds divided by root 2, root 3, the sine of pi fourths, 2. Now this looks like a terribly horrific problem, but it's not that bad. Just go nice and slow. Okay? Now before we do anything, remember to think of the unit circle. Okay? Remember tangent is defined as sine over cosine. And these values we're just going to come up with right now. Okay? So if I'm looking at the sine of pi thirds, remember it's going to be, I'll just root 3 over 2, right? Pi thirds, root 3 over 2. So I'm going to rewrite that right there. The cosine of pi, well, pi is right here. The cosine is -1. Tangent of pi fourths. Pi fourths is technically root 2 over 2 over root 2 over 2, which is 1, right? The tangent of pi thirds is a little bit trickier. I'm going to give you that triangle a little more specific, okay? So I have root 3 over 2 over 1 over 2. Okay? Now if you remember that tangent is sine over cosine. If I have sine divided by cosine, and I do the complex fraction, I just get root 3. Okay? There we go. Now I'm going to take the determinant of that in just a minute. I'm going to remind you what I just did, and we'll do that in a second. Okay? Now, let me simplify that. So root 2, root 3, the sine of pi fourths, I think we already did that one, right? And the sine of pi fourths, root 2 over 2. And when I have a 2. Now, I have that kind of cleaned up. And here we go. Determinant is, remember this, A, B, C, D. It's going to be AD minus BC, correct? So if I multiply this out together, let's see, what does that give me? Root 3 times root 3. I can write it like this if it helps you. Root 3 times root 3 is root 9. Root 9 is 3. So I get 3 halves. So I have 3 halves subtract a negative 1. Well, that's really plus 1. A common denominator would give me 2 over 2, correct? Well, that gives me 5 halves. So this right here gives me 5 halves. Okay? Now I have 2 root 2. 2 root 2. Subtract root 6 halves. Now this is going to look a little confusing. I'm going to go like this. Okay? I need a common denominator. I need these answers in exact form. So let's see. Can I write this as this? 4 root 2 minus root 6 over 2. So I have 4 root 2 minus root 6 all over 2. Now I got to clean that up. I can't have all that junk there. That's a complex fraction. That looks hideous, right? So I'm going to take this real quick. Okay. Now I'm going to have 5 over 2. Where am I? Divided by, I'm just going to rewrite it a little bit neater. And as a complex fraction, I take the reciprocal of that denominator, correct? So now I have 2 over 4 root 2 minus root 6. Well, doesn't that cancel right out? So now I really have 5 over 4 root 2 minus root 6. Now, the problem is I need that cleaned up again. I have a radical in the denominator, right? So I'm going to take that problem. I think that's where it was. Give me 1 second. Here we go. I need a complex conjugate. So now I'm going to have 5 over, you remember this back in Algebra 2, right? Plus root 6. Oops, sorry, I lied. Minus root 6. Now I have 4 root 2 plus root 6. 4 root 2 plus root 6. And when I start doing this out, let's see what happens. I have 20 root 2. 20 root 2 plus 5 root 6. Now, when I multiply this out, remember we just have to do the first and the last? Well, the first is 4 times 4 is 16. Root 2 times root 2 is root 4. Root 4 is 2, right? So that gives me what, 32 first? And the last isn't, what does that give me, negative 6? And what does that give me, 16? Where am I? Oh, I'm sorry, I don't know what I'm saying. Is that 26? I think that is. Does that give me 26? And, we're good. That is all. I know some of those are a little bit tricky, but, you know, just put pause and watch again, and you'll be okay. Good job.